that you want to start it now, though, do you?
It's 5 minutes out. I don't want to have to worry about it later. I want to focus on the presentation.
Okay, so
No, that's okay.
Right now.
So I can pause it.
I see my recording. Great.
Good afternoon, everybody. This is Sue Brunell. Welcome. This is our third in a series of 4 web discussions. So yay, very exciting. And this one today is on database development to organize and track outcomes. So I'm here today in Sacramento with Kylie and Rebecca and going to be turning it over to them.
Good afternoon, everybody. For those of you who have not participated in one of our Introduction to Data webinars yet, welcome. For those of you who have, thank you for sticking with us. Today, we're going to be talking about database development to organize and track outcomes. And really what we're hoping to accomplish with this webinar is just sort of either provide some inspiration or some reminders for best practices in database development as your sites start moving towards collaborating with your partners to obtain and use data for program planning. Okay, so today we're going to talk about designing databases that track quantitative and qualitative outcome data. We're going to talk about Excel. I'm not going to go too much into the detail with Access, as well as more specialized statistical analysis software such as SAS, ArcGIS, which can be used for mapping, which is ARC Geographic Information Systems, Stata, NVivo, and SQL. We're going to talk about steps of database development, maintaining, and also just briefly talk about HIPAA requirements and who should be accessing databases when we have protected health information. If you have any questions throughout the presentation, please put them in through chat and we'll have Sue Grinnell sort of facilitate that. We also added in a few extra slides after talking with a couple of folks from one of the sites on more qualitative examples and some screenshots of some qualitative software that we use. So I'm hoping that those are helpful as well. So this is a redundant slide with our previous 2 webinars, but we think it's helpful to reiterate. We just want to acknowledge there are some sites out there, this is your first at bat with database development and database management. Some of you are on third base, ready to be waved home. You are experts in this. You have your epidemiologists and your researchers in your room with you right now. You are using these advanced statistical software programs. So everybody's sort of starting from a different point. So another sort of benefit from this webinar we're hoping is to sort of identify experts who are using this so that sites can rely upon each other, as well as ask our team here at PHI for technical assistance as needed. This is a short presentation. It's going to be a little bit longer than our previous 2. I think this one's running at about 30 minutes, but we should have about 20-25 minutes here at the end for folks to talk about their examples, their success stories, or potentially their challenges with data development and database management. You're also free to ask us specific questions as well during this time. And as a reminder, we are always available to you. Our research team would love to help you talk through things or sort of troubleshoot or help problem solve with any of your data related questions. So program descriptions. Everybody in the room is probably familiar with Excel. I will go into a little bit of detail with Excel today. Some advanced statistical software programs include SAS, statistical analysis software. This is software we use here at PHI to merge and analyze large databases. In addition to doing just basic descriptive statistics, you can also do advanced multinomial logistic regressions and really kind of get into sort of some advanced level statistics to sort of understand and compare groups amongst each other. The same can be said for statistical package for the social sciences, SPSS, and STATA, which is data analysis and statistical software for professionals. These 3 programs are really for an advanced statistical analysis user. This is someone who is familiar with research methods and practices in analyzing data. They are not user-friendly. Excel is much more user-friendly than these 3 programs. So you really have to have an understanding of what you'd like to do and have some programming experience to be successful with those. Geographic Information System is mapping software. So not only can this map out information for you, but you can do analyses and sort of compare data sets and do merges. This can also be complementary with SAS, SPSS, and Stata. SQL is structured query language. This is more for database linking and sort of obtaining and managing large data sets. It is not traditionally used for analysis. We're also going to talk a little bit about NVivo and Dedoose, which are also similar to Atlas TI, which are qualitative and thematic analyses software. I want to talk first about Excel, which in my own humble opinion is an incredibly powerful and seriously underused program within the Microsoft Office suite. A lot of the times for simple analyses, Excel is all you need. You can conduct univariate and also several bivariate statistics easily in Excel. So not only can you obtain and enter and clean data into an Excel database, you can do some analyses in Excel as well. You can use it to set up your databases for importing into SAS, SPSS, Stata, etc. for advanced analyses. And I'm going to go now and talk a little bit about an Excel database. So I have a very simple example here. And can you see this on your computer soon? Yes. Okay. Let me make this a little bit bigger. Okay. So this is a very, very obviously basic example of a simple data set. One thing I want to point out with this data set that we'll talk about later is that it's set up. It's simple. There are no additional columns. There's no formatting. There's no rows. I do have some things that I'm going to go over right here in terms of analyze pardon me. Sorry, I do have some examples down here of some functions that we're going to run in Excel, but I just want to point out that there's no additional formatting up here at the top. There's no highlights. When you're creating a database, you really want to keep it simple. Another best practice with databases is that you want to include a code book. So you can see here in column A, I have the ID, I have the sex of the participant, their age, whether they've been diagnosed with diabetes, and if they have been diagnosed with diabetes, whether it's type 1 or type 2. You always want to include a code book. So this can be done in Word. I recommend putting it in the same Excel database, but in this code book, I'm going to see what each of these codes mean. So for sex, I have that 1 equals male and 2 equals female. Age is a continuous variable. If they've been diagnosed with diabetes, 0 stands for no, 1 stands for yes. If they are a 1 and a yes, and they've been diagnosed with diabetes, is it type 1 diabetes or is it type 2 diabetes? This is going to be helpful if you are preparing a data set that is going to have further analysis in advanced statistical analysis software. You want to avoid having words or text strings. It's a lot easier for your research or your biostatistician or your epidemiologist to have numbers to analyze, so to have variables as numeric instead of text strings. So just going over some simple analyses here. A lot of the times in Excel we can do, I'm going to go over average, so average. All the functions will usually pop up right here. If I hover my mouse here, this will say this is going to return the average arithmetic mean of its arguments, which can be numbers or names, arrays, or references that contain numbers. So if we're going to do the average, so what's the average age of my sample? Select this. It's going to give me the average. If I want median, same thing. And so you can see I've obviously used these functions before and know what to type in to get it, but there's also a function bar up top that can do the same thing. So mode equals mode. Okay, so just looking at the distribution of age, we can see that we can calculate the mean, the median, and the mode. And what's nice is when you set this up in a separate tab in Excel, if you find that you need to correct the data, so if I say, oh, whoops, it looks like participant Number 12, their age was actually 99 years, not 45 years. And if I enter that in, it's going to automatically update the rest of my data. We can also do some advanced bivariate statistics. So you can do correlations, chi-squared, standard deviations, paired t-tests. You can technically do odds ratio and other advanced logistical analyses in Excel. I do not recommend that. This starts getting really complicated. This is when it's usually better to start relying on SAS, SPSS, or Stata for some of these analyses. But if we were going to do a paired t-test, what I like to do is go up here to the function bar. If I click function, you can put in t-test. It's almost like a search. Here's the function I want. And this is going to let me know the function argument. So it's almost sort of like a widget to walk you through during your analysis. So selecting your two data ranges, the tails, and it always gives you a definition of what the function is going to do down here. So we want a two-tailed t-test, so we would put in a 2, and the type. So if it's a paired t-test or a two-sample unequal variance t-test. So Excel can actually do a lot of bivariate statistics for you. Kylie is a researcher on staff who actually runs a lot of our statistical analyses on SAS. Kylie, do you have any tips or tricks you'd like to share with folks in Excel versus SAS?
Well, my preference is to use programs like SAS. This is where we differ. But that said, I guess, part of the point here is that you really don't need advanced statistical software to run some basic analyses. But what we do always recommend is, be sure to consult a statistician before deciding what sort of analysis you plan to do. It's always important to just make sure that there's logic behind the type of analysis that you plan to carry out.
Absolutely, thank you. So in talking about that, we're not going to go through specific examples of SAS, SPSS, or Stata. These are programs that are on the pricier side. I mean, what does our SAS license cost? Is it like
I think it's over $1,000 a year.
Yeah.
So it is very expensive.
Yeah. So it's definitely worthwhile for us because we conduct a lot of advanced statistical analyses on a regular basis. But if this is just a one-time deal, it might be more cost efficient for you to subcontract with a researcher or epidemiologist if you don't already have one on staff. So these are specialized softwares, again, as we said, that do take advanced training in statistical methods. So we're not going to go through specific examples here today. If everyone's ever interested in learning more about that in the future, please contact us. We'd be happy to work with you one-on-one with that. Same thing with SQL, which is database management. This is just language that you can use to engage with other data sets. You can update data in data sets or databases. It's a program that kind of helps all the databases talk to each other. Again, you're getting you or your staff will need to know SQL language and programming in order to be able to operate this effectively. It's probably not necessary for a lot of the outcome variables that we're going to be using as part of these site goals and outcomes. But again, if you were interested in learning more about SQL database management and how that could help you or your programs, please feel free to reach out to us. Oh, good. So we talked about this in a slide. So as Kylie said, work with your biostatistician or researcher. Hint, hint. PHI Survey Research Group can help you with this if you ever need advanced statistical help down the road. Okay. So now we're going to move on to qualitative data. So quantitative data is going to be more numeric, so yes, no, and things that can be captured pretty easily. Qualitative data, this is more verbiage. So think about recording audio, recording video, transcribing an interview, so more qualitative information. So we do analyze qualitative information differently than we do quantitative information. We are going to be identifying themes, categorizing things into common categories, and basically synthesizing information so that it can be summarized and identify themes to help you make program decisions. NVivo, Dedoose, and Atlas TI are some qualitative software programs. We're going to go through a few examples with Dedoose and NVivo. So I'm going to talk about Dedoose first. And the reason I like Dedoose, well, this is just sort of, let me talk about Dedoose first. So the reason I like Dedoose is that it's fairly inexpensive. I think is it $12 a month, Kylie? Do you remember?
Something like
Yeah.
that, yeah.
So you can get a month-to-month license per person. It's $12. So if you just had a short-term project and you wanted a research assistant or one of your project level staff to sort of help code data for a researcher to analyze later, getting this $12 license can really help with coding. And it doesn't need to be on an annual basis. So it's affordable. Dedoose will help you combine and analyze mixed method data. So this is just a little flow chart of how Dedoose will work within traditional qualitative analyses. So if you have interviews, if you have field notes, if you have audio recordings, if you have video recordings, if you have paper and pencil notes that somebody's going to type into a Word document, an Excel spreadsheet, all of these things can be imported into Dedoose and then manually coded by somebody so that you can identify themes and develop a coding and rating system. It really helps you sort of drill down as with what all the qualitative data is representing for your site. Dedoose connects data. So again, this is sort of what I described before, maybe in a different graphic. So you have your media, you are going to kind of identify your descriptors. So who are the participants, their age, their genders. We're gonna then go into a coding tree. So a coding tree is basically just a way to sort of classify the data. This can either be done, and everyone kind of approaches it differently. I think you and I approach it differently, Kylie. You can sort of take a high-level view of all of your qualitative data and decide on a coding tree in the beginning. So if you know you want to identify, let's say, people who tend to like the color blue over people who tend to like the color red, you're going to come up with some codes on color preference that came up in conversations and code for that. Alternatively, you can kind of look at each media expert individually and start identifying your themes as you go through and process the data. But blocking out the text to determine meaningful research questions can help. This is a screenshot of what Dedoose looks like. So once you've gotten your license, you've imported some of your media, you can see that I have a text excerpt here, and I've got my codes as well as my coding tree. So when I'm looking at this, and I guess one best practice with qualitative data, always have a quote, or excuse me, a code that's great quotes. Because as you go through your qualitative data, this is something that can really make meaning out of your analyses. So just having some powerful quotes that can describe the results. These are oftentimes shown in those little text boxes highlighted in a report, but your code tree will help. So this one, for example, is whether the reading was done by the mother, how long it was, what was the routine of the reading, whether it was a bedtime routine, a morning routine, or other. So when we get to the end, we're going to be able to classify this data and make meaning out of it. And the coding, when you're actually in here, I won't do a dynamic example of this because it's a little bit hard to get in my conference room here, but it's almost just like highlighting as you would with a Word document. So you can highlight words, sentences, or entire paragraphs and assign a code to them. And this is just a close-up of a coding tree coding data within the code tree. So now we're going to talk a little bit about the NVivo screenshots and example, and I'll have Kylie, who uses NVivo to analyze our data, talk a little bit about that as we go through it. But Kylie, do you want to talk about maybe the pros and cons of NVivo versus Dedoose in your experience?
Sure. So they're very similar programs overall. They both achieve the same outcome. So they're just methods for analyzing qualitative data. You can use them to store your qualitative data. And then, of course, as Rebecca has been explaining, apply codes and analyze your data by looking at those codes and how codes interrelate with each other. NVivo is a bit of a different software program. So Dedoose is online. NVivo is a software that you download onto your computer. The version that I have was just a one-time fee, and now I own the software. If I ever want to upgrade, I would have to pay for an upgrade fee. But that said, it doesn't necessarily end up being that expensive if you can get the funding up front to pay for it. I like NVivo a little bit more than Dedoose personally because I found that it was very user-friendly. It has a similar interface to just Windows or Microsoft. So It's very intuitive in that sense that you kind of know what the, like how to navigate within the system and what the navigation bar means. And it's very simple. You'll just basically highlight text and drag a code onto it. Within your coding, you can add color, you can add imagery to help make meaning of the codes. You can also create subcodes. So for example, if you get coding and you end up, classifying a bunch of different things as different types of lung diseases, for example, you might decide, hey, I want to group all these together as just a big lung disease code. So you could do that, or vice versa. You could start with a bigger code and decide that you need to split it out. It's really easy to do things like that. The other thing, my familiarity being greater with NVivo, I know you can very quickly create graphics. So you can generate word clouds and kind of little causal maps almost that show the interrelatedness of different codes. And those are just, at the click of a button. So it's very easy.
Let's go through some examples with that.
So this is what the interface looks like. As I say, it kind of looks like Microsoft Word, very intuitive. What you're looking at here is my code tree. So these are codes that I've generated from interviews, and you'll see that there's a little plus button next to some of them. That means that within community, for example, there are other subcodes. This is an example of a word cloud that was generated. So to create this, I clicked on one of the codes, which was food and nutrition, and all of the content that was coded as food and nutrition was pulled to create this word cloud. So these are the common words that came up that had been coded under food and nutrition, and these were quotes from interviews.
It looks like you can even customize like the color scheme of the word cloud.
Yeah, you can customize it. You can also decide that you don't want to include some of the words, if they're redundant or you don't know why they were included. You can just literally click on one of the words in the word cloud and tell it to not include that. But the way that it analyzes this data is the bigger that the word appears, the more frequently it came up in the quotes. This is another example of what I was talking about. It's showing the interrelatedness between two of my codes. So this is food and nutrition and chronic disease. And it's talking about all of the documents that had those two codes in common. And one thing that you can notice right off the bat is that a lot of the documents or the interviews that were conducted talked about both food and nutrition and chronic disease. There were some that talked only about food and nutrition and not chronic disease, but none of them talked only about chronic disease. So that would be, a way of understanding how those codes are related. And then this is just an example similar to what Rebecca showed with the Dedoose interface. There's some text that's highlighted, and over on the right-hand side, there's a coding pane. So it shows you, for example, homelessness is hot pink. And there's a large section of text that has been coded as homelessness. And then there's substance abuse and community. So it's showing you all of the different codes that are going on within a section of text. And I could click on homelessness, or I could click on text to find out more about that code.
And you know about how much the one-time license to NVivo is?
I want to say when we paid for it, it was a little over 1,000.
Okay, so same thing as SaaS, but there's no annual renewal.
Yeah, it's just a one-time fee.
Okay, great.
Can we maybe just stop a minute? This is a lot, just to check in with people. I just wanted to check in and see how folks are doing. I know this is going pretty fast. There's a lot of information. Any questions or questions about terms that are being used, or some practical pieces that you're thinking about? You can either speak up or use the chat box.
These platforms. I think one of the things I find a little harder to conceptualize is maybe like the coding and the data definition dictionary. So is that something that your staff could be available to provide some sort of light touch technical assistance on if we needed it.
Absolutely.
Great, thank you.
Great. Okay, any other questions before we move on? Sorry, Rebecca, I just wanted to, no, it's great. It's a lot. A lot of info. So, great, okay.
Okay, I'm putting participants back on mute. Okay, so one thing we wanted to cover really quickly too is, okay, so one thing we wanted to cover quickly as well was just sort of data display in PowerPoint. We were talking to a site about this, and I just wanted to point out quickly, I'm sure many folks are familiar with this, but there's a lot that you can do with displaying quantitative or qualitative data in PowerPoint. And if you have the Microsoft Office suite, it's free. So I'm actually just going to go through on my screen right here. I've kind of showed the alphabet and going through and how they're all related to each other. But here we go. So when I click on this, you can see that it actually lets me edit this in this little box over here, which can be really convenient if you're actually going to be typing in some verbiage to show connections between things. And I also just wanted to show these formats or the designs for the layouts that you can do in displaying these data. So in your PowerPoint suite, under Smart Art Tools, you're going to have a tab that says Design and Format. And when I go to the Design tab, when I have this little drop-down menu here, it shows me all the layouts that are possible. So just using this to kind of show relationships between data. Is that showing up on your screen? Shoot. Yeah. So I'm sure most folks are familiar with this. This is just sort of a reminder that this is a really good tool for kind of showing relationships between data and sort of displaying some of your qualitative data or potentially quantitative data in a nice way. This one you can actually show pictures and upload the pictures. Okay, so lots to explore there, and of course you can always customize the color scheme to match with your own site branding. Let's see, oh yeah, here we go. Okay.
And just to jump in, for those who aren't familiar with this feature, to get started, I believe you would go to Insert and then select Smart Art.
Sure. Should we do that? Let's just do that now.
Yeah, go to the
New
Insert.
slide.
Yeah.
And then we've got this little thing
Oh, yeah,
right
I
here.
need
It's
to
just
do
going to
that.
pop up. So insert a Smart Art graphic.
Mm-hmm.
And when I click on that, and it kind of breaks it down for you, we're going to have list, processes, a cycle, a matrix. If I want to display my pyramid scheme for my granola bars, you know, relationships between things, there's a lot that we can do here. So, works out well. Okay. Thank you, Kylie. So, kind of closing in here, just some general best practices that we have found after, you know, between the two of us, I'd say 15 years of trial and error. Always retain an untouched native copy of your data sheet. So as soon as you receive any data, I would just resave original copies so that you can always go back. We call it raw data. So you can always go back to the raw data. If something gets corrupted, if something gets deleted, you'll always be able to have that native copy to refer back to. Copy the database into a separate tab for cleaning and analyses. This goes back to retaining that untouched native copy. We talked about this in the beginning, keep them simple, especially if you plan on coding these with qualitative software or analyzing them with advanced statistical software. I think we have the tendency to try to make our charts and our graphs and our data sets look really pretty and look really intuitive. For a researcher, that's just more cleanup work. We really want to keep them simple throughout. You, in Excel, can write macros or use pivot tables for formatting tables, data, charts. Again, Excel is an incredibly underused program. There's a lot we can do to create dynamic charts, tables, to kind of display data and show relationships between two variables. Again, if you ever have any questions about that, we can provide technical assistance or help you set something up. You're noticing a theme here: create backup copies, don't lose your database, don't lose your database. We're going to touch briefly too on just Health Information Privacy and Protection Act and database security. For databases with protected health information, the best practice, and your IRB, Institutional Review Board Administrator, will inform you of this, you need to restrict the number of users to only those that need access. So for instance here, if we have a database and it includes HIPAA information, we do not provide access to this database to everybody at our site. Only the people who will be cleaning and analyzing that data should have access to the database. We have everybody who will be utilizing a HIPAA security or HIPAA database take a security training and have a human subjects training. There are many programs online through the National Institutes of Health or the CITI program that provide free trainings. Know what constitutes protected health information. You can't be sure if you're using a database with PHI until you understand what those variables are, and we'll go over that. PHI is individually identifiable health information, including demographic information that relates to an individual's past, present, future physical or mental health condition. So this is a medical diagnosis. The provision of healthcare to the individual, or the past, present, or future payment for the provision of healthcare to the individual. Individually identifiable health information will identify the individual, or there's a reasonable basis to believe it can be used to identify the individual. So when we say that, I want you to think maybe about, if you identify somebody as age 55, female, living on First Avenue, you may not be able to identify them, but if we're talking about a small tribal community that maybe only has 100 people living on the reservation area, that information could constitute protected health information. You would be able to identify that individual, and all survey responses or diagnosis information you have for them. So understanding what constitutes PHI in your data set is helpful. Again, if you have any questions about that, we are here to help you interpret that, or your IRB administrator, if you have one, can. This is a good, oh, it got cut off a little bit. At health.gov sites, it'll give you a PDF with the law for privacy and security guide. So this is what IRB will utilize when referring to it. But just in general, so you'll have a data set with protected health information. You can de-identify that data set. So you can take a data set that has protected health information, and you can make it so that it is no longer going to identify people. Generally, this is not comprehensive, but generally by removing people's names, a geographic area smaller than a state, date, so my date of birth, my date of death, my medical discharge date, my telephone, fax, or email address, my social security number, medical record number, my account ID, my driver's license number, my birth certificate record number, any photographs of people, any IP or internet protocol addresses, essentially anything that can be used to trace back to the person. Remove that, you've got yourself a de-identified data set. That is what we have for today. I know that this presentation kind of went a lot into the weeds, and again, we want to acknowledge that there are some sites that are doing this work already, that are utilizing NVivo and SAS and coding and cleaning data sets. That are some that maybe potentially have never even heard of these programs, and this is a new sort of introductory phase, and there are some that are in between. So I'm going to unmute the participants somehow. Let's see. So that we can talk about questions. Oh, I got it. There we go. Manage participants. Okay, so folks are unmuted, and the chat box is being monitored by Sue. So if there's any questions about what we've presented today, or if anybody would like to share stories or provide some tips that maybe we didn't cover in this presentation on best practices with obtaining, cleaning, or analyzing data using these softwares, or just best practices in database management, we would love to hear from you and sort of acknowledge the wisdom in the room.
Hi, this is Martin from Enshin. Have we talked about whether or not we need IRBs and how we might look at that?
We here at, I have not, I have.
No.
Okay. No, oh, during this data webinar?
no.
No, we have not.
That's something you're wanting some information on, Martin?
Yeah, I mean, we've done that before, but I'm sort of not recalling exactly what gets us into that arena.
Mm-hmm. I'd be happy after this webinar to send out, I think, is it the CDC or NIH has a nice little, is it NIH? They have a nice little 3-pager on what constitutes needing IRB approval, or at least an application to IRB, getting exemption or expedited review. So they kind of have some good parameters. I mean, for us, we tend to always just check with our IRB administrator to make sure and try to get an email back saying, no, you don't need to submit this to IRB, but they have a good resource. So we can send that out after this webinar to folks.
Great, thank you.
Other questions, comments, concerns, or just tips, tricks, or success stories that folks would like to share about using these softwares or working with protected health information data sets?
So this is Sue. So we are recording this. I was thinking as Rebecca was going through showing different things and clicking here and here, I thought, oh, this will be helpful to have that recorded. So, and then the slides will be available. And I just want to reiterate that they are here for assistance. So if you're, thinking about what you heard today and you're wanting to kind of explore this more, please reach out to them. That's what they're here for. I think, one piece is, you use the term make meaning, right? It's part of our framework. And as you're doing world cafes or you're talking to people and, I see Jennifer on, we were in Napa last week and we had a wall full of data of people's feedback. That's a lot of kind of qualitative data, to be able to try to make sense of it. And so I think as you're doing that, it might be a new way of thinking about or doing business. And so we are here to help with that in particular. So great. So next week will be the overview of metrics. So we're going to be giving you a little bit of information on what is a surveillance system and what are metric sets, and giving an example of metric sets, and then going into the core metrics. And then when will they actually get the core metric data?
within 24 hours of that webinar.
Okay, so then each of you from the 9 sites will get your own core metric data, and then we'll explain more about that this next week, which I'm very excited about that. So very good. So any more questions before we end? Okay, well, great. Well, thanks you guys. Have a great day.
Thank you.
Thank you.
Thank you. Thank you.
Stop that.
Just, do I have to do anything to,
No, because you put cloud, right?
yeah.
Yeah, so it'll go to the cloud. Just stop recording.
I did. So end meeting.
I don't think you did.
I don't think you did.
just stopped
because I
sharing.
still see the red.
What?
So stop share. Okay, and now
Stop recording down there next to the chat. Next to the chat.
there's somebody on chat.